Okay, the following information is to answer questions 13 to 14. The time in minutes that Liv ran each day was recorded on 9 days. These times are shown below. Okay, so we've got a time series here. Both 3 median and 5 median smoothing are being considered for this data. Both of these methods result in the same smooth data value. Okay, so what we're going to have to do is we're going to have to, and you have to say on which day would they produce the same value. So I'm going to do in the pink, I'm going to do a 3 median smoothing. So when you do 3 median, you take obviously the first 3, you're looking at the first 3 numbers, and it would be, when you think about it, if you have 3 numbers in order, it'll be the second one in from lowest to highest. So you can get a ruler and you can just move from the bottom of the page up to up the top. And so I'm going along all these first 3 dots, and if you look at it, you hit this one first and then this one second. So this first smooth value data is in line with that second dot. So it'll be here. So there's the first one. And then what you do is you take the next 3 numbers. So it would be day 2, 3, and 4. And once again, you go up those 3 numbers. So the first, and you get the second highest. So the first one would be this day 3, and then the second one would be the day 2, the second highest. So it would be in line. So I'm saying in line with that. So there goes there's the second dot. So you would just keep on doing that and mark off all of them. So remember with 3 median smoothing, you'll lose the first and the last piece of data. So you'll lose the first and last. So you'd only have, because there's 10 days here, you'll only have 8 pink crosses on it. So I'm going to go and finish the 3 median. Okay, so now I'm going to finish the 3. I'm going to do the 5 median smoothing with the purple colour. So with 5 median smoothing, the first one, I'm going to take in the first 5 numbers. And my first cross will be along the third one. And so therefore the third highest will give me, or from lowest to highest, the third highest will be the median. So here, if I go through, this one looks like, see, this is first, then came this one, second, and this one is actually the third. So that's actually where I'm going to have my first cross. Okay, so now, and we just keep doing, so we'll do the next 5. So I take this one off and I look at the next 5 numbers, so it'll be along here, and up I go. If I just go through those 5 numbers and I'm looking for the third highest from the bottom, so I'm going up, it looks like this one was first, then we have that one second, and then we look like we've got this one's third. So it'll be in line with this number. Okay, so if I keep going and I'm up to the 5th day. So the 5th day, there'll be a cross put along here, and I'd be using, what I'm looking at are these 5 numbers, and I go up through them. One turn I find the third highest, which is here, and there are, so I'm going to continue doing the purple, and hopefully I haven't hit it yet, but one comes the similar number. Okay, I finished that, and with 5 medium, you're going to lose 2 at the start and 2 at the end. Okay, at end, so you can see why I've only got 1, 2, 3, 4, 5 because I've lost 4 out of 10. Okay, and when I did that, I saw that day 7 was the one that was the same day. Okay, so let's go on. The least squares line is to be fitted to the time series plot shown above. The equation for the least squares line with day number as the explanatory, so you know that day is x, so up here, x and y. So you just have to do, when they say the least squares line, you have to just type them into your calculator and list in spreadsheets, which I've done up here. And then you obviously go do a linear equation, select day and time, and we're looking for an A value of 28.5 and a B value of 1.76. So you can see that's how I found that day. Okay, with question 15, it's asked for the median monthly rainfall for 2017. So the median is when you would put them all in order from lowest to highest and then find the middle number. So because it's months of the year, you have 12 numbers, okay? So it would be in between, you'd put them in order from lowest to highest if you were trying to find the median. And so it would be in between the 6th and 7th one. So you can do like you did with the ruler before, where you start low start with the lowest, and you want to go in between the 6th and 7th. So if I go through them and I go up with the ruler, that would be 1, and it looks like we've got 2, 3, 4, 5, and then 6 and 7. So this looks, even there, I think this one is the 7th there, highest. So what you can see is then you get your ruler and you want to go in between those last 2 dots. So this was the 6th and the 7th, okay? So in between that dot, there's actually a line, and it ends up being out here. So we can see that it's on 110. So you'd be looking for an answer that's between 100 and 110 at least. So here we go. The only answer there is D. Okay, now it asks if the 7 mean smoothing is used to smooth the time series, the number of smooth data points. So before we saw that 3 you lost 1, so 3 and 5 you lost 2. With 7 median smoothing, you'll end up losing 3 at start and 3 at the end. So in total there'd be 6 missing, so out of the 12, so 12 minus 6, and then we get 6. Okay, the next size in centimetres of 250 men was recorded and displayed in a dot plot. So here we go, we know an n equals 250. Write down the modal next size. So modal is the most frequent, so the biggest column you're going to see. So we can see here it's on 38. So we'll just say 38 centimetres. Now, assume the sample of men has been drawn from a random population whose next size is normally distributed with a mean of 38 and a standard deviation of 2.3. So they're saying, when they say that it's normally approximately distributed, that means we can use the bell shape. So we're going to use the bell shape. And sometimes it's just easier if we just draw it straight away. So they said a mean of 38 and a standard deviation of 2.3. So how many of the 250 men are expected to have a neck size more than 3 standard deviations above or below the mean? So what you need to know is when you go 1 standard deviation, 2 standard deviation, 3 standard deviations. If you're up there and then you go -1, -2, so you're -3 standard deviations. If you check with your notes, these little pockets down here, and that pocket down there, they're worth 0.15% of the population, or the number of things you've got. So if you're going to find above and below that, you'd actually have 0.15% plus 0.15%. So you've actually got 0.3% of that. So what you would do is you want 0.3%, so over 100 of the 250. And you end up with 0.75. So it said round to the whole number, so it'd be 1 is your answer there. Now it says of these 250 men, actually, how many of these, 250 men actually have a neck size of more than 3 standard deviations above or below the mean. So we probably need to know what neck size is 3 standard deviations and above and below. So what you would do every time you're adding 2.3, add another 2.3, add another 2.3. So if to 38 you add that, you'd be adding another 6.9. So it'd be 44.9. So if you go over to the salmon leaf, that would be up here, and there's no dots above that. And now if we go back, so if we minus 6.9 from 38, we end up with 31.1 down here. So we look at, is there any lower than 31.1? So there's that line, and we can see there was one lower. So this one, there was one actually in the real data. There was actually only one lower, plus or minus 3 standard deviations. Okay, so a scatter plot of bone density versus weight measurement has been drawn, and they've given you the equation here. So this is the equation here. So the linear regression, so that's your A and that's your B value. Okay, use this equation of the least squares line to predict the body density of a man who has a waist of 65. So you just use the equation there that they've given you. So it's simple, 1.195 minus 0.001512 times 65. And just be wary, and hopefully you highlight 2 decimal places so you can check your answers at the end. Okay, so I get the answer to be 1.096. So if I round that to 2 decimal places, it ends up being 1.10. Okay, so there we go. Using this equation of least squares line to make the prediction in part B, are you extrapolating or interpolating? So if you look, you've got to look for you're looking for the 65. Is it outside your data or inside? And this would be inside and 65 would be in there. So that would be interpolating. If you were getting, interpolating. If you were asked to predict on the outside, so a number less than 60 or more than 130, you'd be extrapolating. Measured in. Okay, interpret the slope of the least squares line in terms of body density and measurement. So in any interpret question, you will have a fill in the blank. So because it says interpret the slope, which is actually the B value, and we can see that interpret the slope. I've put that on our notes. So we need to get the equation from the other page. So with the equation, this was the B value here. So it's a negative, and so it means we'd be writing this statement out. So I'm going to just write it in our template because you can do it on your exam. So I would say the RV, which is the body density, it decreases. The word decreases takes into account that negative, so you just have to write the values. So decreases by 0.001512 Now, after that, you want to write the B value and R units. So I've just written the B value and the RV units. So there was whatever body density, which was kg per litres, and then you have to write the waist measurement. So you put the EV there, D increases by 1, and you write which was centimetres, the unit for the EV. Okay, moving on. In this study, the body density of the man with a waist 122 was 0.995. So what they just gave you there was an actual when his X was 122, so when his waist was 122. Show that the least squares line is fitted to the scale, but that the residual rounded to 2 decimal places is. So if you write out your rule for residual, it equals actual minus predicted. Okay, so if you the actual, they gave it to us, so we know that is here, 0.995. And the predicted, you have to use the equation. So I'm going to use that equation again. And minus 0.001512. And then I times it by the X value, which was 122. And then you end up with your answer. So they said round to 2 decimal places. So you can see 2 decimal places will end up being negative 0.02. I think the number on your calculator was negative 0.0155. So 2 decimal places is how we got. This is our final answer here. Okay, so the next question, the coefficient of determination is this. So sometimes you miss this information, so really try to read all of it, and I like to put R squared there, so I remember. So write down the value of the correlation coefficient. So that's just R. So to get R from R squared, we have to do the square root of the R squared. So in this case, it'll be the square root of 0.6783. Now, we have to decide whether it's a plus or minus. Is the R value plus or minus? Once we've done that as well. So if we do the square root of R squared, we'll end up with 0.824. Now, we know it's negative, and we know that because the gradient, the B value, is negative. So that means the graph is going downwards, which it was, like it was a downward scatter plot. So it means the R value would be a -1. Okay, once again, make sure you highlight the 3 decimal places and that your answer is in those 3. Okay, so once they do all that, they've shown you now a residual plot. Does this residual plot support the assumption of linearity? And in the data, briefly explain. This is on your summary sheet, so I'll just show you. Okay, so when we see no clear pattern, which here is no clear pattern, in the residual plot, then that supports that or confirms that it's linear. So all you have to do, does the residual plot? Yes, as there is no clear pattern in the residual plot. Okay, so that's all you have to write. Okay, question 6. The table below shows the mean age in years and mean height in centimetres of 648 women. So just sometimes it's good to write that N that's given there. What is the difference between the mean height of women in their 20s and the mean height of women in their 80s? So mean height in 20s and mean height in 80s is there. So you just simply go 167.1 minus 156.1 0.7 and equals 10.4. Okay, so then the next one, it says describe the association in terms of strength and direction. So you can see from the graph, the dots are very close to the line, so that's a strong, and it's going downwards, and so that indicates negative. Okay, in this next question, they're saying that the line on the scatter plot passes through this point and this point using these 2 points. So you had to just use this data because they've said to use these points. Determine the equation of the line. So obviously the equation of the line is the A and the B. So you can just use these points as like mini lists. So this will be your X and your Y, and this is an X and a Y. So you can see I've popped them in. So see here I wrote mean age and here's mean height, and I put the 20 and 168, and it's just like we've got a mini list, and then I've gone and done the lin reg, and I've made sure I picked, because I can see the mean age is the X value, and that's why I put the X, and I can see that the mean height is the Y, and I've popped them in and then do a lin reg, and we can read off these A and B values. Now just be careful, it's saying, hopefully you've highlighted it, 3 significant figures. So if I go and do that over here on the calculator, you start counting as soon as you have a non-zero. So there's 1, 2, 3. And then what we're looking at is the fourth one and whether we round up the third. Because it's 3, we don't. So we can see we've got 171. And if we go and do the B value, so we don't start counting till we have our first non-zero, which is here. So 1, 2, 3. And then we're going to look at the fourth value. It's a 2, so the 9 doesn't need to go up. So we can see we've popped in that number. Now we need to put the negative in there, even though this says plus. So we need to have the negative written there because it's a negative gradient. Okay, so we continue on and we can see they did a residual plot. And so the residual plot indicates there's an association between mean height and mean age is non-linear. So why they say that is it's non-linear is because there's sort of like a pattern. So because there's a pattern in the residual plot, that equals non-linear, which means we will probably do a transformation. So moving down in the question, it can, and they do say that, it can be linear by applying an appropriate transformation. And it says apply an appropriate transformation to mean age. So they want you to transform the mean age. So for us, that was the X value. So we need to do an X transformation. And then it says, and they want you to find the least squares line. So when they want that, that means they just want the Y equals A plus BX formula. So I need to go and look at that circle transformation. So this guy over here. Now this was the original scatter plot. It's on the other page. So you can see it sort of curves that way. So it would be part of this part of the circle, which means these two transformations are appropriate. And you can see there's only actually one X transformation, which is X squared. So that means I'm going to do an X squared transformation. So what you need to do is you need to type your first original list in. So you can see I've got the mean age and mean height, and then I have to create a list of these ages squared. So I just called it SQ age. And then what you do is you just, in the formula bar, you write equals. Now because I wrote mean age, I'll have to type that out there. And then I just square it and press enter, and the squares. And then what you do is you go get your lin reg again. So just remember when you're typing in your X list, it'll have to be the square age because you've got to use your new transformed list, and your Y list will still be mean height. You only ever change one. And then we can see we get the A and the B value, and we just need to make sure we're doing it to 4 significant figures. So you can see, so 4 significant figures, so you don't start counting till you have non-zeros. So you can see 1, 2, 3, 4, and this one 1, 2, 3, 4. Okay, a class of 25 children in year 5, 15 girls, 10 boys, sat for a mathematics test. The mean score test for the girls was 28.5, and the mean score for the boys was 25.5. And they want the mean score for the whole class. So if you write out the formula for mean, what you actually do, the formula for the mean is you add all the values up and you divide by the number there is. So when we're trying to find the mean, there's definitely, well, we know there's 25. So we need all their values added up. If you have a look though, we did have the mean for the girls separately. So if you look at that, it would be add up all the girls and then divide by 15. So because we know that the girls' mean is actually 28.5, you could find all the girls' weights added up by going 28.5 times 15. Okay, so that would be all the girl values. And then, so that would be all the girls' values, and then you could do the same for the boys. So you've got 25.5 equals all the boys' values, but over 10, because there's only 10 boys. So then if you do 25.5 times 10, that'll give you all boy values. So this is a way to those two, if we grab these two and add them together, that tells us this value up here. So what I'll do is I'll just pop them in. So put the girls, it'll be 28.5 times 15, and it'll be plus the boys' values, 25.5 times 10. And then you just keep going and do that calculation on your calc, and you'll get the mean, which is 27.3. So we end up with 27.3. Okay, Ruth sells eggs. From the past experience, Ruth knows that the mean weight of eggs that she can sell is 56 grams. And she also said 2.5 of these eggshells have a weight greater than 65. Assuming that the weights of the eggs are approximately distributed. So as soon as we see this, it's talking about this bell shape, okay? And so therefore we know they did tell us the mean was 56. And they told us this percentage that they said 2.5% is greater. Now, if you go up 1 standard deviation and 2 standard deviations, if you go up 2 standard deviations, this pocket up here is actually 2.5% of the data. So when you have there, so we would know that above this line is 2.5%. So they said 2.5% have a weight greater than 65. So I know that's 65. So then when the question asks, assuming the weights, the standard deviation of this data is, so they want the standard deviation. So if the distance between here and here is 2 standard deviations, all you have to do is go 65 minus 556 divided by 2 will equal 1 standard deviation, which will equal 4.5. Okay, so there we go. Okay, so consider the following amortization table for a reducing balance loan. So it'd be important to know what you're talking about. And the annual interest rate for this loan is 3.6%. So that is, they've just given us sometimes I on our final finance solver, or it's the per annum rate. Interest is calculated immediately before each payment. The loan for repayments are made. So they want this, what they want remade. It's really the PPY. They want to know how many times a year is this getting compounded. So what we're going to do is we can look at the amortization table, and we could maybe use like interest, because that's going to have how many times per year. Now, the interest amount is found by doing the rate per annum divided by PPY over 100 times the balance before. So if you look, PPY is our question. We can get everything else. I'm going to use this 900 interest amount will be, now I know the R, it's 3.6, divided by X is what I want, PPY, and I know the balance before was here, was 300, so 1,000. So we could pop that in and do solve, comma X, and we're going to get X to equal, so X equals 12, so 12 would mean that it's monthly. Okay, so we've got C. Okay, Samuel has a reducing balance loan, so here's a reducing balance loan again, and the first lines of the amortization table for Samuel's loan are shown. Interest is calculated monthly, so you do get a little bit of information there. You know, PPY is 12, and he makes monthly payments of 1,600. So if we were thinking of finance solver, if we wanted to, that payment, because he's making payments, that'll be a negative 1,600. Interest is charged on the loan at 3.6 per annum, so that is the I, in finance solver. Now, using values in amortization, calculate the principal reduction of payment number 3. So with a loan, a reducing balance loan, you can see that the payment, you make a payment, but you first have to, in a loan, pay the interest off. So the payment minus the interest equals the principal reduction. So when they ask for this 3, we simply just have to do the payment minus the interest. So that it'll just be 1,600 minus 956.15 and equals 643.85. Okay, calculate the balance of the loan payment number 4 is made after payment number 4 is made. So the question is actually, we need this this box here. Okay, we have to think about how that's done. So this value, the balance is normally the balance is found in a loan is found by doing the balance before minus the principal reduction. I've spelled that wrong, but principal reduction. Okay, so if we look here, we know the balance before, it's that one, so 318,074.23 minus the principal reduction. So I need to find this principal reduction here. Okay, so, and we know that was found by doing the payment minus the interest. So we need to find the interest. So using that thing I said before, remember the interest amount is always equal to the R over the PPY over 100, and we can do times the balance before. Okay, so in this case, the rate per annum, they told me that was 3.6 and it was monthly, so 12 over 100 times the balance before, which was, so for this one, it's this one here, so 318,074.23, and we'll get the interest. So I got the interest to be 954.22, so that would be in here, the 954.22. So now I can work out that principal reduction Okay, so I can see now that it'd be minus the 954.22 will equal the principal reduction, which would be 645.78. So this will be, we can put that over here, 64578, and we can find the balance of the loan, which would be 317,428.45. So you can put the balance of the loan 428.45. Okay, now it says let SN be the balance of Sam's loan after n months and write a recurrence relation. So I've gone to my thing because this was a reducing balance loan. So I've gone to this formula here, and this is where we get the recurrence relation. So we need to write out this, okay? But obviously we don't want to use V, we want to use the letters they've used. So they're using S. So SO is the original amount, which I can actually see from the table. It began with 320,000. And then I need to write this rule part, which will be Vn equals R. Now, the R you'll have to calculate. So R is equal to 1 plus the rate per annum, which is 3.6 over 12 over 100. Okay, and if you do that, you get 1.003. So now I can write the SN plus 1, because it'll be the R, which is 1.003, the big R, this big R, times SN, don't use V because they won't do one, now minus D, and if you look here, D is the regular payments, which we can see is 1,600. So there we go, there's the recurrence relation for that. Okay, question 9. Samuel opens a savings account. Let BN be the balance of the savings account after n months. So this is a monthly formula. Write down, so the question is write down the value of B for 4 months after. So when you've got a recurrence relation, we can just do it like quickly on our calculator. So this one, pop in the 5,000, press enter. And that is actually obviously BO, and then when you press enter, then if you press times, you'll see answer time comes up, and we want to times it by 1.03. So this is B1. Once you do that, you can just keep pressing enter now. So B2, B3, B4. So then you can see that the answer is 5060.27. Okay, to the nearest cent, which means 2 decimal places. So calculate the interest rate percentage for calculate the monthly, interest rate of Samuel's savings account. So this is a monthly formula. So there in, that bit in there is actually just this bit is the extra interest rate being added, but once it's been divided by 100. So that means when you're trying to find the actual percentage as a percentage, we just take that 0.03 and we times that by 100. So it'll actually be 0.3% is the monthly. Okay, after 1 year, but the balance of Sammy's savings account is this. Okay, so that was the normal, and if Samuel had deposited an additional $50 at the end of each month immediately after interest was added, how much extra money would be in the savings after 1 year? So this amount here was the amount without the extra, without the payments. So we probably want to find the total with the payments. So remember, 1 year would be 12. The interest rate we know is 3.6. He began with, if we're going to pretend if he still invested 5,000, but now we're going to say he's going to add an extra 50. So he's giving the bank, it's negative. And if we find out the final value there, and the PPY is 12. So we find out here, and you can see I've done it there. So we've got 579. If you round that, it says to the nearest dollar. So that would be, this would be 5793. So how much extra? So when he does it with the payments, he gets 5793, and without it, it was 5183. So if you minus that, and you'll end up with 610. So there's your final answer. Okay, question 10. Samuel now invests 500,000 in an annuity. He receives regular monthly payments, and the balance of the annuity in dollars after end months can be modelled by this recurrence relation. And calculate the balance in the annuity after 2 months if K equals that. So I just did the same recursion thing in our calculator. So you put 500,000, then if K is that, so I'm going to times it by 1 point and take away. So this would be 1 month and then 2 months. So if I wrote down what the 2 month was, it would have been 498,398.08. Okay. Now it says calculate the annual. So this is interest rate percentage if for the annuity if K equals this. So the annual annuity is the rate per annum. Okay, so that's what annual is. Now this K, because this is used in a monthly formula. So if you look at this is an investment. So I've gone over here and we've got an annuity investment, and if you look at the R here, we've found the R value. That's what we've got in this monthly formula. So I have wrote that out here. So we know this was what K is, and the R is what we're trying to find out, because we know it's 12 ppy, and then you can just solve and we end up with 2.88. Now it says, for what value of the K would this investment be a simple perpetuity? So here we have to go to the perpetuity part, and what we want is this payment to be, well, the payment would be 2,000, and what we want is the interest earned to equal 2,000. So the interest that you gain is just generally so you want is here. So the interest that you gain is this part of your formula. So I've written 2,000 equals R, because we're trying to find out what the rate per annum is. So if I write, well, I want D to equal 2,000. So if I do that, so I'm actually using the D formula because I want that to equal 2,000 in a perpetuity. So we know that it's 5,000, and we do that. And if I do that, the rate is 4.8. So if I was trying to find the monthly rate, because that's what K is, K equals the monthly part for the formula, I'll just do this. So 1 plus, it'll be this part of the thing. So 1 plus 4.8 over 12, and I get 1.004. Okay, later Samuel took out a new reducing balance loan. The interest rate for the loan was 4.5% per annum. So there it's telling me an I, compounding monthly, so PPY equals 12. And we've got the balance after 4 years and here, and the balance after 7 years. Samuel will continue to make the same monthly payment. So he is making a payment. Okay, so to ensure the loan is fully repaid to the nearest cent, the required final payment will be lower than the first 7 years. Will be lower. In the first 7 years, Samuel made 84 payments. Okay, from this point on, how many more monthly payments will Samuel need to make? So if we go through things that we've got, we need to know how many more. So if I look, so at the 7 year mark, we want to know how many more payments. So how many more repayments, that would be the N is the question. And then if I go through what I know, so I know the interest rate is 4.1, and I know now the PV, I actually don't know that. And the payments, I also don't know. And also if you look at the final value, well, at the 7-year mark, and we want to zero it off, so I know that's 0, and PPY is 12. So because I have a couple of things missing here, I'm going to have to go find them. So the first thing I'm going to do is I'm going to use these years here to find the payment, because what I can do, when I'm going to pretend that 4 years, at the end of the 4th year, that's the beginning of a loan, and then I'm going to say 3 years later I have a value, and that would be at 7. So up here I've put 3 years, so 3 times a year, and I've got the interest rate, and I've put in this like we're beginning the loan, so it's positive at the start in a loan, and this is the question, and at the end of those 3 years I still owed this amount because I've got that there, but that would be a negative, and we knew this one. So we can see the payments, we work out the payments are negative 2,400, so we get that. Because we want to find how many more from this 84, we can pretend at the 7-year mark, we'll just pretend like we're starting again. So my PV, sorry, this one was in the wrong area. Sorry, payment should have been in this one. So negative 2,400. My PV will be like the start of the 7 years. So I'm going to pretend like I'm learning this, what the value was at 7 years. So I'll pretend I'm starting again and I'm borrowing that. And if you want to obviously zero it out, and if we do that on the calculator here, we get that it to be 149.7. Now you haven't paid it off, so it says how many more monthly payments. So you haven't paid it off on 149, so you need to round up and say, even though they said the last payment will be adjusted, or it would be, they haven't said, but you will adjust the last one, but it's still a payment. So you'd say 150 more payments. Okay, Leonard hasn't invested an amount in a perpetuity. So because it's perpetuity, I've gone down and got our note looking at that. And the perpetuity earns 4.8% per annum. So that's like the R or the I in Finance Solver. And it says interest is calculated monthly. So PPY equals 12. And if Leonard receives 1,600 per month. So they just told me that's like the payments, okay, from the perpetuity. The amount that was invested, so that's actually like the VO or the beginning, or maybe the PV. Now, if we look down at Finance Solver, the PV and FV are the same value, but we don't know that, so we can't use Finance Solver. So what we're going to use is this D, because D equals the payments in this formula. So we know that that's 1,600, and if I use the formula, it's rate over PPY over 100 times VO. So I do know the per annum rate, which was 4.8, and I do know it's 12 over 100, and VO is the only thing that I don't know. So I'm calling it X, and I can pop that into solve, X, and I will get the value of the investment. So we get X to equal 400,000. So that's how we get that answer. Okay, town B is located on a bearing of 60 degrees from town A. So from town A means that's where you're starting from, you're bearing from. So if I draw A and we draw our little compass, so you start from A's north line and you go out 60 degrees. So 60 degrees would be in there, and then we'd see, you know, B would be located out there. So the only diagram that's like that is C. Okay, all cities in China are on the same time zone. Wuhan is 31 north and 114 east, and Chengdu is 31 north and 104 east in China. On the same one day in January, the sun set in Wuhan at 5:50 p.m. Okay. Assuming 15 degrees equates to 1 hour difference, longitude. So longitudes are the east and west values. So there's that. So if you look at the difference between these cities, the difference at the moment is 114 minus 104. So it equals 10 degrees. So they're saying 15 is 1 hour. So if you do 10 divided by 15 times, say 1 hour, which is 60 minutes, you'll end up with 40 minutes difference. Okay, the further east you are, you will get the sun first, so you'll therefore get the sunset first. Okay, so if you think about it, assuming the 15 degrees longitude equates to 1 hour, the time set in Chengdu. So this guy, Wahoo, gets it at 5:50 p.m. and it gets it first. So therefore, 40 minutes later will be Chengdu. So 40 minutes onto 5:50 is going to be 6:30 p.m. Okay, so 4 identical circles of the radius r are drawn inside a square as shown, and the diagram below the region enclosed by the circles has a shaded in the diagram. The shaded area can be found by using thing. So what you can see, if we have a look at these radiuses, try to draw the radiuses together. So you can see you've got a radius here, and when I do that, I end up with a square, and I've got a square, and it's like 2 radiuses wide along there. Okay, so there's the square. So if I found there's the area of that whole square, that would be here, that whole area there. Now if you have a look here, this parts of the circle, it's like I've got I have a quarter of the circles there. So, but I actually have 1, 2, 3, 4 quarters. So 4 quarters, if I added them all up, I end up with 4 quarters. I'd have the area of a circle with those bits. So if I took, if I minused the area of this square minus those circles, I'm going to end up with that shaded bit, because what I'd be doing is I'd be taking, don't want to do that. I'd be taking away this bit, these bits here, and you'll be left with just the black bit. Alright, so we can see that we've got a whole area of a circle. So an area of the circle is found by going pi r squared, and the area of a square would be found by going 2r times 2r. So that would be 4r squared, and then we'd be minusing that pi r squared, and so then it would equal our answer. So there's B for our answer. Okay, so when you read through this question, you've got a tower that's 80 metres high. So that's pretty important, because what I do is I can draw these triangles along here. and because they end up being right angle triangles. So we've got those if you think about it. And so this bit is the tower. So this side is the tower and there's the tower. And they've given us that distance. So, but when I can use the tower, and I know that, and what I actually can do is I can find the distance between C and B. So I've labelled this triangle. So say I call that X, it means I'm finding that distance in there. And if I do the other triangle, I might call that Y, that would be here. Now, if I think about just the map version of what's happening, so just a map or along the ground, this is what I'm seeing. So you can see C, A, B along the ground. And I've drawn out that triangle. So really here would be X and Y. And we got given a few bearing information. So we'll do the bearing part first here. So the bearing of landmark B from A is 105. So I've got that is 105. I've drawn it here in the blue for 105. So little things that you find out, you can see along the way. You know, you'd have right angle triangle there, 90 degrees. So if that's 90 degrees into that line, I can see that this little bit is 15 degrees in there, because it's right. So we can see a little bit, and if that's 15, we know that in here is also 15. Now they said I've highlighted in the pink, from the bearing of landmark B from the lookout tower. So when you see the word from, that means that's where you're going to start. So from the lookout tower, so you can see I've done that, is 142. So if that's 142, then also that distance from there to there, because you've got parallel lines, is 142 as well. So if you've got 142, now you know 90 of it is there. And we also can see this little 15 degrees in there. So 90 plus, so we can see that's 105. So in here, this angle in here must be 142 minus 105. So that will be 37. So we know that's 37 in there. And some other things so we know that's 37. So let's go look, and they want in the end, the question is the direct distance between the two landmarks. So this is the big, I'll just call it Q. This is the question here. We need that. So we've got to look at what we've got. And so we also, so we've got that this is 37, and we now probably need to get this X and Y. So I'm going to use them and get them from these purple triangles up the top. So I'll go do them now. So with this, we are just finding, we can just use Pythag, where we can say 234 squared equals 80 squared plus x squared, and you can do solve and you can find out what x equals. And over here we'd have the same thing, but we'll have 170 squared equals y squared plus 80 squared, and you can solve and we'll find out what y equals. So I just found them out. So I know is 220 and y is 150. So it's getting quite crowded. So now I'm just going to draw a more simpler triangle. And I know that's 37. And I might call this C, this is B, and this is A. And I know that this is 150, and I know this is 220. So I'm actually trying to find this side here, so little c. So I'm going to have to go off and I need another angle. So I'm probably going to have to go then use this triangle, get another angle, and then maybe use the cosine rule. So I'll do this on the next page. Okay, so this is the question that we're needing. So we need this side. And we're probably going to need to use the cosine formula where we would use this, and this angle here. So I can't get that angle yet, but I can use the sine rule to find angle A, and therefore I'll be able to find angle C. So this is a lot of work, but it's one of the last question. It's the last question in the unit, so it's going to. So I'm setting up over here to find angle A. So sine B, little side B was 150 over sine 37, and equals 220 little a over sine, and A is what I'm trying to find. So, you know, I'll just call it A if I want to. So now I'm going to do solve. And if you remember, we're going to go comma A and close that bracket, and we're going to restrict it using on our calculator doing this. So we'll go do that. Okay, so I probably, if I'm using the letter A for my unknown, I should actually put in the calculator A there. So whatever your, or capital A if you use, whatever you put for your unknown, you need to pop it in there. So even if, probably easy just to use X here to find it. So use X anyway. So we do that and we get X could equal, I'm going to round, 62 degrees, or X could equal 118 degrees. Okay, so we're going to take the 62 because we can see in the triangle that it's not 118. It's not bigger than a right angle. So we'll go with that. And if we do that, and then we can now use, because to find this Q side, so then I'll use the cosine rule. So I'm wanting to find little c, and if I follow through my formula sheet, it'll be a squared plus b squared minus 2ab cos angle C. So actually I haven't found angle C yet. So if we're saying this is 62, this is 37, C would equal 180 minus those two added together. So we can do that. Okay, so then I get C to be 81. So it's 81 there. Okay, so now we know that that's 81. We can pop all the data into here. So little a is 220 squared plus 150 squared minus 2 times 220 times 150 times cos 81. And when you do that, you end up with, rounding to the nearest whole number, is 246, and we get that answer. Okay, so with this, the cake in the shape of 3 cylinder sections as shown in the diagram. Each section is of height 8 centimeters. So that height is the same in every one. The middle section of B is twice the volume of the section in A. So they're sort of giving us a comparison of the volume here. So if you look at the volume, and we might call this it's actually their volume ratios. They're getting compared. And we'll say A to B to C. So B is twice that of A, and then they say C is twice that of B. So if B is 2, C will be 4. Okay. Now, they've said the volume of the top section of the A is thing, so volume. So we've got an actual number there. And then they want you to find the diameter of C. So remember that diameter is equal to 2 times the radius. So we probably need to find the radius. And the first thing we could do is find the radius of radius of A. And I'll do that by using the volume. So the volume of the cylinder was 900, and the formula for volume of a cylinder is pi r squared times h. So we know what h is, it's times 8, and then you can pop in solve comma r, and we end up with the radius being 6. Okay, so now we want to use, now these are similar figures, so radius, now we need the radius of C. But what we have to be careful with is when you have 3 dimensions change in the similar figures, you would do the cubic root. So if we were given volume and we were going back to the length ratio, we normally do the cubic root. But that's when all 3 dimensions change, which I mean by is the length, the width, and the height. If only 2 dimensions change, so if only 2 dimensions change, you only have to do the you only have to do the square root, which is actually like saying 2, so 2 dimensions changed. And so in this case, the 2 dimensions have only changed. The width and the length, they've both changed in similar figures, but the heights remain the same. So if we want to go back to this, just the length ratio, all we have to do for this one is actually just do the square root. Now we're only talking about A and C, so I'll just do the square root of those 2. So the length ratio equals a 1 to 2. Okay, so when you were trying to find the radius of C, the radius of C is going to be A's and times 2, which equals 12. So this is the radius of C. But remember, they want the diameter after all of that. So denominator is 2r, which would be 2 times 12. So that's 24. Okay, so with this question, we have a recurrence relation using matrices. So when we have these, we use as transition, but when we have these extra bits, you always got to find the next one. Find next one using the one before. So you can't use the power trick or whatever, and you just got to always go step by step up to get to where you need to go. So when they say determine, this was the number in 2 weeks, in the second week. So when they want the third week, 3, using the formula, it'd be T times the one before, which will be R2, and then it'll be plus the B. So you've just got to pop all of them into your calculator. So the transition up there times this R2 here, and then you've got to add this matrix. So you just type it all out on your calculator, and they want what's in Westmore, so you'll get this 3 by 1 answer, and they want what's in Westmore. So if we do that, we get, so Westmore we get 237,966. That's what would be in that spot. Now, determine the expected number of shoppers at Westmall in the first week. So this way you have to go backwards. So if we first think about how we would have found R2, so R2 would have been found by doing the transition times R1 plus B. Now, because this one here, R1 is the one we don't know, but so we don't know this one, and that's what we're trying to find, but we know this one, and this one. So you sort of got to work backwards, and the first thing you would have done is minus the B. So you'll take the R2 and you'll minus B because you're going backwards. Okay, so R2 is there and the B is there. So you do that first, and then what you would do is you want to times by the inverse of T, and because it's at the front, it has to be at the front here. So you can pop all of that into your calculator exactly like that using brackets, because you want the B to be minus first, and you'll end up with an answer, and this will be 1. And they still want to know how many shoppers at Westmall again. Okay, so we'll go backwards and we'll do that on the calc. and we get 241. So Westmore in the first week was 241000. Okay, and that's the answer to that. Okay, so with this question, we've got 3 television channels. Gillian, that they're looking at 2,000 residents, and they options to change to not to watch TV and to change to the channels, each channel. So here is the state matrix who are to watch the games on the channel on a particular day on 9 a.m. and this thing is changing from hour to hour. So this is this hour, next hour. So they're pretty much giving you the first state matrix. Now, to complete the calculations, show that there are 835 Gillians expected to watch at 10 a.m. So that would be G1, or the next state. So if you think about how you'd find G1, is you do the transition times GO, and then you'd end up with your G1, and there'll be C1, C2, C3, and no TV. Now they want you to show how 835 appears here. So if you've got to go back to manual multiplication now, because this number is in what we say, well, it's in row 4, column 1. When you were multiplying to find this, you would have used row 4 out of this one with column 1 out of this one. So you can see what would have happened is this row would have been multiplied down with that. So what 100 would have been multiplied with is 0.15 from there. Then 400 would have been multiplied by the 0.25 and 0.2 and 0.50 and so on. So to determine the number of residents expected to watch the games C3 at game C3, so on channel 3 at 11 a.m. So 10 a.m. was G1, 11 a.m. is going to be G2. So you're going to say, to find G2, you do the transition to the power of 2 times GO, and then we're going to get an answer. And we'll have C1, C2, C3, and no TV. And we want the answer at C3 at 11. So we'll just go do that. When you do that, you'll find that 356 is written there. So how many are meant to? So you just write that out, 356, and there's done. Okay, in this one, the basketball finals will be televised on Channel 3 from 12 to 4 p.m. It is expected that 600 residents will be watching C3 at any time from 12 noon to 4 p.m. The remaining 1,400 residents will not be watching C3 from 12 p.m. to 4 p.m. The transition below shows how 2,000 residents are expected to change their viewing habits each hour, okay, watching C3 and not watching C3 from 12 to noon. So up here, you needed to know there was some vital information, and it was right here. They said that it is expected 600 Gillian will be on C3 anytime between 12 and noon. So even though the hours are changing, you're going to have, so say if this was your beginning matrix, say state 1, and you've got C3 and not C3, they're saying it's always going to be 600 and it's always going to be 1,400. So even if I go to S2, this is going to remain the same. So with that, we can work out a few things. So we've got to they've said this is a transition matrix, and then we need to work it out. So the first V is quite easy because we know they have to add up to 1. So I'm going to use the V, so we know that's got to be 0.65, okay, because 1 minus 0.35. Now the other two, we don't know. We can't add them up to 1 because we don't know both of them. But we know if we do the transition and we times it by, say, the S1, which was 600 and 1400, we know we get the same answer, 600 and 1400. So what you can do is you can do manual multiplication and you can set up an equation. Now, we know if we were trying to find this answer here, so this would have been, this is row 1, column 1. It means we would have used row 1, column 1 to find the answer. Now, we know this is 0.65 now, so I could say 0.65 times the 600 plus W times the 1400 equals 600. Okay, so if you look here, we've only got one unknown, so you can pop solve into your equation here, comma W, and we're going to find out what W is. So we get W to be 0.15, so, and we know now they have to add up to 1, so if W is 0.15, then X must be 0.85.